Welcome to another method of undetermined coefficients example. So let's go ahead and consider the equation y double prime minus 2y prime minus 3y equals e to the 3x times cosine of x. And our job is to find the general solution. So the very first thing we want to do is just check our characteristic equation. And so we have characteristic equation r squared minus 2r minus 3 equals 0. So this factors as r minus 3 times r plus 1 equaling 0. We get r is either 3 or negative 1. So e to the 3x cosine x is not a solution. We don't need to worry about that. Is not a homogeneous solution. So we're in the more simple case, right? From our characteristic equation, we can get that our homogeneous general solution is y equals c1 e to the 3x plus c2 e to the negative x. We can do our particular solution. Our f of x, our right-hand side, we had, let's see, we had y double prime minus 2y prime minus 3y equals e to the 3x cosine of x. So our initial guess we should have includes an e to the 3x cosine x. And we didn't have a polynomial component, so we can just use an a naught. And then we will have a b naught e to the 3x sine x. As we saw, there is no need to multiply by x. And so we can pick our yp. Our guess that we'll wind up with is just yp equals a naught e to the 3x cosine of x plus b naught e to the 3x sine of x. From here, then, we plug this in and solve for our coefficients. So we will plug in to y double prime minus 2y prime minus 3y equals e to the 3x cosine x and match coefficients. So we need to know we have yp as a naught e to the 3x cosine of x plus b naught e to the 3x sine of x. Our first derivative, yp prime, we would have a 3 a naught e to the 3x times cosine of x. And product rule, we would have a minus a naught e to the 3x sine of x. Then from our second term, we would have a plus 3b naught e to the 3x sine of x. And then plus b naught e to the 3x cosine of x. So if we combine our terms here, cosine, we would have a 3a0 plus b0 times e to the 3x cosine of x. And then we would have plus 3b0 minus a0 times e to the 3x sine of x. Finding our second derivative, we were looking at yp double prime. We would have a 3 times 3a0 plus b0 e to the 3x cosine x. Then we would have minus 3a0 plus b0 e to the 3x sine of x. That's the product rule on that first piece. And from the second piece, we would have plus 3 times 3b0 minus a0 e to the 3x sine of x, and plus 3b0 minus a0 e to the 3x cosine of x. Condensing this and simplifying it down, our cosine terms, we have 9a0 minus a0, so we would have 8a0. And then we have 3b0 plus 3b0, so we would have plus 6b0 e to the 3x cosine of x. Then we have a 9b0 minus b0, so that becomes a plus 8b0. And then we have a negative 3a0 minus 3a0 minus 6a0 e to the 3x sine of x. If we plug this into our equation, we would start off, these get really messy really quick. We would start off with 8a0 plus 6b0 times e to the 3x cosine of x plus 8b0 minus 6a0 times e to the 3x sine of x. That's our y double prime. From that, we subtract 2 copies of y prime. So y prime, we are looking at 3a0 plus b0 times e to the 3x cosine of x. And then we have plus 3b0 minus a0 times e to the 3x sine of x. And then for our last term, we had minus 3y, so we have minus 3 times a0 e to the 3x cosine x plus b0 e to the 3x sine of x. And this whole thing should be equal to e to the 3x cosine of x. And then you could do plus 0 e to the 3x sine of x if you like. So our job is to condense that left-hand side. So in terms of cosine coefficients, we have an 8a plus 6b0, and then we have a minus 2 times 3a0 plus b0, and a negative 3 times a0. So for our cosine coefficients, so focusing on cosine, we're focusing on e to the 3x cosine x. We have 8a0 plus 6b0 minus 2 times 3a0 plus b0 minus 3 times a0. This has to match the invisible 1 in front of that e to the 3x. So simplifying this side down, we have 8a0 minus 6a0 minus 3a0 becomes negative A naught. And then we have 6B naught minus 2B naught is plus 4B naught. This should equal 1. And focusing on sign, we have 8B naught minus 6A naught. Then we have a negative 2 times 3B naught minus A naught, and then a negative 3 times B naught. So for our coefficients now, focusing on e to the 3x sine of x, we had 8B naught minus 6A naught. Then we have minus 2 times 3B naught minus A naught. And then we had minus 3 times B naught. And on the right-hand side, we have 0 e to the 3x sine x. So this should equal 0. So again, we're forcing the coefficient on the left in front of e to the 3x sine x to match the coefficient on the right in front of e to the 3x sine x. So for our A naughts, we have a negative 6A naught plus 2A naught. That becomes negative 4A naught. And then for B naught, we have 8B naught minus 6B naught minus 3B naught becomes minus B naught. And this should equal 0. So at this point, we are solving a system. So we need to solve the system negative A naught plus 4B naught equals 1. And negative 4A naught minus B naught equals 0. You could do elimination, substitution, whatever technique you want. If we multiply this bottom equation by 4 and add them together, this becomes negative A naught minus 16A naught, so negative 17A naught is equal to 0. Sorry, is equal to 1. So we get that A naught should be negative 1 over 17. So we have plugging in negative 4 times negative 1 over 17 minus B naught equals 0. And we should get that B naught is therefore 4/17. And that does satisfy our system. So we now have particular solution. YP is equal to negative 1 over 17 e to the 3x cosine of x plus 4 over 17 e to the 3x sine of x. So putting these all together, our general solution we would have y is equal to y1 times c1, which c1 was, I believe, e to the 3x. Sorry, c1 times y1. So y is equal to c1 times y1. y1 was e to the 3x plus c2 times y2. y2 was e to the negative x plus our particular solution. So we have plus a negative 1 over 17 e to the 3x cosine x plus 4/17 e to the 3x sine of x. So again, these problems, even without the polynomial component, are rather horrific to solve. Add in the polynomial component and they get to be quite messy. But this is the technique we have for using method of undetermined coefficients. In the next 2 sections, we will look at 2 alternative methods that we can use for solving for our particular solution and general solution, which are maybe not quite as messy.